In this video, we're going to take a walkthrough of the MapReduce architecture. We're going to look at MapReduce version 1 versus MapReduce version 2. We'll do an individual daemon walkthrough of all the daemons in MapReduce, and we'll take a look at the configuration files that MapReduce uses. First of all, let's look at the key players, and this is in MapReduce version 1. We have the cluster daemons inside the cluster, and we also have a client. For the moment, let's say this client is outside of our cluster. We have a job tracker daemon, which is the master daemon, and it does orchestration and delegation of the jobs. We also have one, or more likely many, individual task trackers, each running on a separate machine. These are the slave daemons, and they oversee local map and reduce operations. Then we also have MapReduce tasks. These are short-lived daemons that come and go as jobs require individual map and reduce tasks. It's the actual map and reduce logic that runs inside of these map and reduce tasks. A quick note on MapReduce version 1 versus MapReduce version 2. MapReduce version 1 is what we'll use in this course, and for good reason. MapReduce version 2 is not production ready. It probably will be ready sometime in 2014, but it is not ready yet. MapReduce version 2 mainly makes our job tracker more scalable by scaling the job tracker or the master daemon function of individual jobs out to the slaves. And it also removes the static definition of how many map and reduce slots or how many map and reduce tasks we can run per slave. We cover these topics in other slides. Let's take a very high-level look at what happens during a job submission. We cover this in more detail in other lessons, but this is a very high-level view of what occurs. First of all, the client submits the job to the job tracker daemon. The job tracker is constantly being pinged or heartbeated by the task trackers. This occurs every 5 seconds. And the task trackers basically say, hey job tracker, I'm alive, I can accept map and reduce tasks. The job tracker is continually looking for data locality opportunities. This means that an available task tracker has some local data that's required for processing. For example, one of the blocks in a map task. The job tracker then decides to assign individual map and reduce tasks to individual machines. It does this by responding back to the task trackers and saying, hey, I need you to run a task. The task trackers then individually stand up map and reduce tasks. Here we show one map and one reduce being created. Really, in a full job, there will be many, many maps and likely many reduces that run as well. Each of these individual map and reduce tasks then report their progress and whether they're completed or whether they errored up to the task tracker. The task tracker at this phase is also watching for the map and reduce tasks to die, and if they die, they will report that up to the job tracker. Otherwise, the task trackers report their progress up to the job tracker. The users during this phase will start seeing the percentage complete march forward in their terminal output. Things like 0% complete on reducers, 0% complete on mappers, and then 2% complete on mappers, 5% complete on mappers, so on and so forth. The users will see that at this point. The job tracker will issue requests for all the map and reduce tasks that need to be run. If any of the map and reduce tasks ran into problems during this phase, this is when the job tracker reaches back out to the task trackers to say, hey, I need you to run this other map or reduce task. Finally, the job completes and the output is written back into HDFS. MapReduce uses many config files. Just like HDFS, every client, master, and slave node is going to have MapReduce config files. The main two files that we use are both in the default location of etc Hadoop conf. They are mapred site XML, which has the core MapReduce daemon configuration, and the Hadoop env.sh file. This is an optional file that sets up various environment variables used by Hadoop. Things like the size and the control of the Java virtual machines, the Java home directory, and so on. Let's actually take a quick look at both of these files. If you have the Cloudera Quick Start VM open, you can follow along with me here. First, let's go to the config directory, etc Hadoop conf, and let's take a look at the files that we have inside of here. Here you can see our Hadoop env file as well as our mapred site file. Let's first take a look at Hadoop env. I'm going to open it in the VI editor. Here you can see that Cloudera has set up several options that we would need for specific daemons. Here we have Hadoop name node options, secondary name node options, and other options specified in this file. We're not going to modify this file, so just push :q to exit out. Let's also take a look at the mapred site file. Again, we see individual name and value properties that we set up for MapReduce. Both the variables inside of here as well as Hadoop env are described in other chapters. And let's quit out of there. In this talk, we walk through the basic MapReduce architecture, looking at the various daemons, the various config files, and the differences between MapReduce version 1 and MapReduce version 2.